WNEP presents a Power to Save special.
Hello everyone, I'm Don Jacobs.
And I'm Jackie Lewandowski.
And welcome to another Power to Save special. Now of course the Power to Save, it's about home, it's about resources, it's about the environment, and of course saving cash.
And now it's off to Berwick, where one dilapidated building is becoming 6 new ultra energy efficient homes.
And here's Tom Clark to show us the Chestnut Street project.
These new homes along Chestnut Street in Berwick are so energy efficient, the owners can expect to pay no more than $300 per year in heating and cooling costs. How can they build a house like that? Come on, let's find out.
With the energy efficiencies, we looked at it as a whole house package. This had the old Chestnut Street School was in a state of disrepair. It was ultimately condemned by the borough when one of the walls collapsed.
Well, our goal for the project was to create high-performance homes with a lot of green aspects to them at an affordable price. 2 of the homes are ranch homes, and they are intended to be sold to a family that has someone with a physical disability. The other 4 homes will be sold to first-time home buyers. Very important to achieve the thresholds that we set. You can't do that with any one system. So it's a very integrated process. Everything works in harmony with each other. We did 24-inch on-center framing, so we have less studs and less trusses. Every time we hit a stud or a truss, we have a weak point in our envelope.
How does that conserve energy?
A wood stud will transfer heat a lot more than an insulated cavity. So by having more studs in a wall, you're transferring more heat from the inside to the out during the winter months.
Does that mean more insulation?
More insulation.
Does that compromise the integrity of the structure of the house?
It is all calculated, engineered, so that a 24-inch on-center wall cavity is sufficient for holding the loads. Right, we use a cellulose green fiber insulation, which is a recycled paper product that's treated for insect infestation, so that you don't have to worry about that.
And one of the unique things that we can do here in a modular plan is spray against the backside of the drywall. So we're applying a minimum of 2 inches of closed-cell spray foam in each stud cavity against the backside of the drywall, and then the remainder of the space in that stud cavity is going to be filled with flow and cellulose.
The structure of these roofs has a higher heel height, which is where the top chord and the bottom chord of the truss come together. We have a 19-inch heel height on these trusses so that we can fit full insulation value right out at the exterior wall. In a normal house, that heel height is usually down to about 0 or just a couple inches. By having that higher heel height, we can fit in an R60 insulation all the way out to the exterior wall.
Since the houses are built and constructed and insulated so tightly, there's very little natural air exchange. What we did is we incorporated an ERV system into the house, which is an energy recovery ventilator. And what that does is it allows us to control the exact amount of ventilation that we need for that house, depending on how many people are living in it. And that not only changes air out for us, it gets rid of stale, humid air and brings in fresh air for the occupants to breathe, but it also goes through an enthalpy wheel and recovers up to anywhere from 50 to 70% of our heat in the winter. We're exhausting that out. So it's going through an enthalpy wheel, recovering up to 70% of that heat and bringing it back into the supply stream.
We've gone with the geothermal heat pump, which is one of the most efficient out there today.
Tell us about some of the vents in the bathroom.
What we do on an energy efficient house is we'll run that ductwork horizontally and run it out through a gable wall so that that heat doesn't want to escape straight up through the roof. And then on the outside of that hard duct, we will actually put on an insulation wrap to encapsulate that pipe so that we don't have cold air coming in through that pipe down through into your bathroom in the wintertime, or the opposite in the summertime. These windows are actually a triple pane window, very well insulated. They actually have krypton gas in between the panes also, so you get better insulation value because that krypton gas is in between there. And they also have low E coatings on the glass panes. All the appliances are energy efficient. They're all Energy Star rated. The toilets are dual flush toilets, so that you use less energy by pulling in less water when you don't need as much water to flush the toilet.
So these homes essentially are roughly 60% more efficient than a conventionally built home. A lot of it has to do with energy efficiency, but we also deal with water conservation. We deal with site development, water runoff on site, trying to get the water to go back into the ground rather than just go into the storm drain. Here at Design, they have recycle bins throughout the plant that for wiring, so the copper gets recycled, the drywall actually gets ground as a blend for fertilizer and distributed to local farms. Recycling the wood or reuse of the wood, so scrap wood gets reused to the extent that it can, the rest of it gets sent out for recycling or use in other products.
We hope to have the first 3 homes ready for move-in the end of October. We will be having an open house. We're going to invite anyone that wants to see what we're doing. So we're going to make sure that we have at least one of the ranch homes and one of the 2-story homes available for tours. So we designed a home that would cost about $100,000, which is about the most that a family with the income we're targeting can afford.
Imagine how much more energy efficient these homes would be using solar panels or wind turbines. But what we see here demonstrates how homes are going green. It's the future of home construction, and it's happening today, right here in Columbia County.